All right, so when we compare and order fractions, there are always three strategies that I would use to do this. The first one is you can draw a picture, or if you're like me and your pictures are not great, create a mental picture, visualize what's happening. So, for example, I have 1/2 and I'm comparing it with 1/4. Those seem like easy pictures to draw, so I'm just going to draw a circle, divide it in half, shade half of it in, draw another circle, divide it into fourths, and only shade a fourth of it in. So that picture helps me see that 1/2 is greater than 1/4. But 1/7 compared to 1/13, I'm going to be honest, if I tried to draw a circle, I would not get it in 7 equal pieces or 13 equal pieces. So this is probably where I would use a mental picture. And I know that if I'm taking a pizza or a circle and I'm dividing it into 7 pieces, those 7 pieces are going to be bigger than if I took that same pizza or that circle and broke it into 13 pieces. Those 13 slices, each slice would be smaller than the slices from the pizza that was only broken into sevenths. So just by that, I know that 1/7 is going to be greater than 1/13. There may be more pieces over here, but that one piece is going to be smaller than the one piece from the pizza that has sevenths. Okay, so I'm going to be honest, I don't use this strategy very often, just because I'm really bad at drawing pictures. So the strategy that I tend to start with is finding a common denominator. And we find a common denominator. Sometimes we can look at it and just see it right off the bat, or we can use our strategy of finding the least common multiple. Okay, if I can get the denominators to be the same, it's like we're cutting that pizza into the same amount. So it's an equal playing field, and all we really have to do is then compare the numerators. So I have the fraction 5/9 and 2/3. Okay, if I want to get to a common denominator, I know that I can turn that denominator of 3 into a denominator of 9. Oops. So my scale factor to get me from 3 to 9 would be times 3. And whatever I do to the bottom, I also have to do to the top. So 2 times 3 would be 6. So 6/9 and 5/9. Well, 6 is more pieces of the 9 than the 5 is. So 2/3 is greater than 5/9. Okay, 9/10 and 11/13. Finding a least common multiple would be 130. So I know in order to get 13 to 130, that's going to be a scale factor of times 10. And whatever I do to the bottom, I have to do to the top. So 11 times 10 would give me 110. And then I also have to turn 10 into 130. So my scale factor here would be times 13 times 13. I'm going to come over here to the side and do 13 times 9, 27. So that would be 117. So I know that 117 pieces is going to be more than that 110 pieces because, again, it's out of the same amount. So 9/10 is greater than 11/13. And last but not least, if you can, this is my favorite way to compare and order fractions, is to turn it into a decimal. Okay, so sometimes we get lucky and they're benchmark decimals or benchmark fractions. So I know that 4/5 as a decimal is 8/10, and 7/8 as a decimal is 875 thousandths. Okay, I'm going to add some zeros to give myself the same place value. So their tenths place value is the same, but I have a 0 for the hundredths and a 7 for the hundredths. Well, 7 is bigger than 0, so 7/8 is greater than 4/5. Okay, then I have 3/8, which I know is 375 thousandths. But when I get over here, I don't know what 5/17 is as a decimal, but I can find out. So I'm going to run through my strategies. I know this isn't a benchmark. 5 and 17 are both prime numbers, so I can't simplify it. I don't have a good way to get 17 to either 100 or 10, so my last and final option is to divide. Put the top dog in the house. So I know that 17 can't go into 5, so I need to add a 0, a decimal that I bring up to the roof, and a 0. 17 goes into 50. Well, 17 is pretty close to 20, and 20 will only fit in there 2 times, so I'm going to start with 2. So 17 times 2 will be 4, 34, and I'm going to try one more just to see. 4 would be 1. Yeah, that would give me 51 if I went 3 times. So 2 is as close as I can get. So I'm going to subtract 34, and I get 16 as a remainder. But here's the deal. I can go ahead and stop because I know that 3/8 has a 3 in the tenths place. And right now, as I'm dividing, I only have a 2 in the tenths place of my quotient. So right off the bat, I don't have to keep going because I know that 3 is more than 2. So 3/8 is going to be bigger than 5/17.